Welcome to all. So now we can concentrate on Boolean functions. Okay, in previous videos, one of the videos where I have given the rough idea of Boolean variables, isn't it? How to build some Boolean functions and Boolean variables, something like some laws you have seen, commutative law and associative law and so on. Okay, so now we will see what is Boolean functions and how exactly you can deal with the functions. Okay, a Boolean function is a function whose arguments as well as the function itself assume values from two element set. Okay, so when you usually see, when we are learning digital logics or computer system, it will be ultimately it will be with respect to zeros and ones, isn't it? Input will be in terms of zeros and ones. So that is the reason why when you have two set of data, you can build some circuit, and using that circuit or using the gates, you can get the appropriate result. So we will see one by one, using the functions, how can we construct some circuits using which we can calculate something. Okay, now usually it will be zeros and ones. As a result, it is sometimes referred to as a switching function. So this Boolean function is also called as switching functions because of its nature, either 0 or 1 or 1 or 1 or 0 or 0. Okay, so at the max you will be having two values, isn't it? Either 0 or 1. So it will be keep on switching based on the variables you pass, or the function you pass, or the instruction you pass to a particular system. Okay, now the next thing is a Boolean expression is an expression that results in a Boolean value, that is in a value of either true or false. See, when you have this concept of computer system, when you talk about Boolean thing, it is either true or false. But in the same fashion, if you want to represent this true or false with respect to numbers, then you can go for 0 or 1, isn't it? Either 0 or 1. In the same fashion, either true or false, something like that. Okay, so that is the reason why we say it as a Boolean value. Okay, now when you have expressions, how can you deal with that and what you mean by that, we will see. The println statement will be executed if wet and cold are cold both are true. So it is one example. They said they have taken some programs. Okay, if you are going for some Java programs or C++, in any programs, if you want to print some lines, and only if both the things are true, something like if there are two conditions, say for example Rama has cold and Sita has also cold, then only you have to print that both are cold, something like that. Some conditions will be there. Okay, so if both the statements are true, say Rama also having the cold and Sita also having the cold, means then that couples will be having the cold, something like some such kind of decisions can be taken by understanding the concept of Boolean values. That is the reason why they say something like this. And if say poor and hungry both are true, some conditions can be used for this Boolean expression. Okay, Boolean expressions are most often used as a condition. So that is what just now I said. But mainly while writing the programming, being as first year students, I don't know how much this languages, programming languages you are evolved in PUC, what subject you have taken, I have no idea. But if you know something about computer programming, definitely the conditions or conditional parts and operators will play a major role. Okay, by taking the variables, by using some operators, and by using some conditions, you can write so many programs. And ultimately, using the condition itself, you will be having the rough idea of programming. In day-to-day life also, as a developer, if you want to write some programs, definitely there has to be some conditions, isn't it? So see, just consider one example here. Okay, say someone says that write a C program to add two numbers if one of the number is greater than 10. Okay, now if that is the question, you have to add two numbers only if one of the number is greater than 10. That means you have to check, isn't it, whether the numbers are greater than 10 or not. That means you need one operator to see that whether it is lesser or there has to be some conditions. So you can go for some conditional statements there. If out of two numbers, if one number is more than 10, then only you have to add the numbers, otherwise leave the program, you just come out of the loop or come out of the program, something like that. Such kind of conditional things can be used, and it can go for true false also if that is the case. And you can go for complex conditional statements also, not just a simple one. Okay, so then in day-to-day life, whenever you write some programs, definitely there has to be some conditions, and you will be using some conditions. Based on that condition itself, this program will take some decision and it will print the output. That is the thing. Fine. So next we will see. So a Boolean function looks like, say they have given an example of Boolean. So function f of x comma y and so on. So there can be so many parameters and equal to x plus y dash plus xy and so on. So it's one syntax for Boolean function. So how Boolean function will look like. Based on that, you can go for next step. I can build the truth table also. You can build the circuit. You can calculate the values. You can get the result also. How? If you can ask, how sir, how you are saying like that? Say for example, in that expression itself, so in that function itself, you can take f of 0 comma 1. If that is the case, x is by default, x is 0 and y is 1, isn't it? Because you have only two things, x comma y. Then so on, leave about that dot dot dot. You just leave about it. You just think that you have only two variables. X value is say 0, y value is 1. If that is the case, how can you calculate the rest of the thing? X is 0, 0 plus y dash. Y was 1, y dash means again 0, isn't it? Plus 0 into 1. Ultimately, what is the answer? Answer will be 0, isn't it? Why? If you assign those values, if you put all those values to that particular expression, ultimately you are going to get the value as 0 itself, isn't it? Because y dash is, y was 1, y dash means complete inversion, ulta. It should be 0, something like that. Okay, where x comma y and so on are the variables or inputs, and f is the output of the output that comes when putting those input into Boolean function f. Okay, they just gone for some standard statements, but ultimately you can do like this. Fine, you can insert the appropriate value to the variables, and you can calculate you can use the expression and you can calculate the result. Okay, now we will see this. We'll see this example will give a better picture to you. Fine, Boolean function, how exactly Boolean function can be used. Okay, see, Boolean expression or function, there is one expression called f(x, y) equal to x plus y dash z. Now your work will be to use or to build the possible values of truth table. If you are having three variables, then how many inputs can be possible? How many types of inputs can be possible? You just have to say, when you have three variables, 2 to the power 3, isn't it? So 2 to the power 3 is nothing. For x you will be having 8, y will be having 8, z will be having 8, isn't it? 2 4 6 8, yeah, total 8. So ultimately, for each and every variable you will be having 8 inputs, isn't it? Total 24. If you add up all the variables, ultimately you have to get 24 inputs, isn't it? For x, say in the first line everything is 0. In the second line you have z is 1. Third line y is 1. For fourth line y and z is 1. Something like that. Some such kind of inputs can be given, isn't it? When you have three variable, how can you write? Isn't it? You can go for up to 7, 0 to 7. Correct? 0 0 0 is nothing but 0. 1 1 1 is nothing but 7, isn't it? When you have three inputs, you have to recall your previous videos, that previous concepts. How to represent 0 to 7 using 3 bits. This is such kind of example you can expect here. So based on that function, don't think about circuits. You just concentrate on that expression f of x comma y equal to x plus y dash z. Now how to do that? When you have all zeros, you have to put zeros to that function, that expression. You are going to get the value as 0. When z is 1, what happens? F is 1 there, x is 0, y dash is 0, y is 0, that dash will become 1, isn't it? Inversion, 0 inverted to 1. So 1 z is 1, 1 into 1 1, 0 plus 1 is 1. Ultimately you are going to get the value as 1. Something like that. Okay, you have to think like that. Now when you have y is 1 and z is 0, then obviously you are going to get the value as 0 itself. Okay, any ambiguity anywhere? Okay, you can go for a 7 last, 1 1 1. So it is something like x is 1, y dash is 0, z is 1. So 1 plus 0, ultimately you are going to get the value as 1. Understood? So you have to apply those numbers and you can check. Ultimately F column, see F in the F, under the F you will get the result by putting the input to those function. You have to put the input to that function and you are going to get the value as a result. Now you can build the logic circuit for this also. How can you build the logic circuit? Now you have three inputs X, Y, Z and output is F. Now what is that gate? How many gates are there? There are three gates, isn't it? What are the gates you have? For X and Y, what is the gate? What is that gate? And for Y you have one NOT gate, isn't it? Why that NOT gate? Because you want to invert the input. Ultimately you are inverting the input, then you are giving you are taking Y answer as Y dash and Z to AND gate. Why AND gate? It is X Y dash into Z, isn't it? X plus Y dash into Z. So Y dash into Z is nothing but AND gate. Now for total expression, what you are going to do? You are using OR gate. Why? X is one part plus Y dash Z is another part. So you have plus. So plus is nothing but OR gate. They are using OR gate. So that is the logic circuit they have built. Now you can concentrate. X is directly passed to OR gate, but YZ, that is separate part of story, isn't it? So Y, they first inverted it. They used a NOT gate. After the inversion, the result is fed to AND gate, and Z is directly given to AND gate. After calculating the answer, the result is given to the OR gate. Ultimately you are going to get the F. So whatever the input you put, F will be giving the exact answer. If you want, you can use the truth table and you can check. You can put the values to those logic circuit, to that logic circuit, and you calculate. You will get the same answer. So this is how this Boolean function can be understood. Okay, like this you have so many examples. See, I have taken some examples from your textbook. Okay, now see, F1 equal to X, Y, Z dash. It is one expression. Now X and Y should be directly given to AND gate, but Y, you have Y dash. That's the reason why, sorry, not Y, Z. Z is having one NOT gate because it is Z dash, isn't it? Directly you are not feeding that particular Z value to AND gate. First you are inverting it using NOT gate, then result is fed to AND gate. Ultimately you are going to get some values or the result as F1. F1 result can be achieved. In the second example, see F2, X plus Y dash Z, the same thing. They have gone for. See, this is one of the representation. You can ask, say in the previous slide, see this expression is same as the previous one, isn't it? X plus Y dash Z. But can you see how they have built the logic circuit? So it is different from this one, isn't it? So ultimately, what is the difference? Both are actually same. You are not having any other differences. Here see, Y and Z they have taken separately and they have fed to AND gate. Once you got the result, X is fed from afterwards X is fed to OR gate and result is given to OR gate, and you are going to get the ultimate function or result. Fine. Like this also you can build, but ultimately your work will be to get the output properly. That's it. However you build, you should not make any mistake with respect to the gates and input to that gates. And when you get the output from that gate, that output has to fed. If it has to fed for some other gates, it has to appropriately fed to that particular gates. In this case, from the result of AND gate is fed to fed as an input to the OR gate, isn't it? Along with the X. In that example 2b, correct? So like this you can build, and you see you have one more, see, somewhat complex, somewhat big one, isn't it? The expression is, or function is, F3 equal to X dash Y dash Z plus X dash Y Z plus X Y dash. Now you have three parts. First part is X dash Y dash Z. Now take appropriately. So write XYZ, then get the lines. For X dash you need one NOT gate, Y dash you need one NOT gate. For Z you don't need gate as of now. Directly you can feed. So there are three AND gates because you have three parts, isn't it? Now all the result of all three AND gate is fed as an input to OR gate. Why? Because you have ultimately the ultimate expression is with respect to plus or adding up the things, isn't it? So you need OR gate. Now see xy you are feeding directly to AND gate. Now see, can you see why they have they are having some intermediate connections? Because instead of writing xyz separately, what they have gone for, they have just taken, they have extended the line. Okay, for x they have extended a line before the NOT gate. But if you want x dash, then what they have gone for, you just see, after the NOT gate they have brought down one line downside, because they need x dash value, not x value. If they just, the expression, the part requires only x value, then you have to extend the line before the NOT gate. But if you want for some parts, if you need x dash value or inverted value, then after the NOT gate you have to bring down the lines, and you have to bring down in the same fashion. You have to put one small circle, and from there only you have to bring, because it's ultimately these are the circuits. You cannot directly pull out some lines. That in that syntax only you have to go, in that representation has to be in the same way. You should not change the representation of the circuits or logic circuit. Fine. So like this you can build the logic circuit for a particular expression. If you have doubt, and you can ask, you don't need to worry much on this. Now see, you have one more expression, f4 equal to xy dash plus x dash z. Now you need a NOT gate for y, as well as you need NOT gate for just a moment, you need NOT gate for x also. Whether they have gone for yeah, they have gone for x dash also. Yeah, so you have x y z, three inputs. That 3 x and y is fed to one AND gate. So in that AND gate, y is having one NOT gate because you are going for y dash. So result is fed to that particular AND gate. But for the second part, you have x dash z. So in the first line you don't have NOT gate, isn't it? Directly they have given that input to that AND gate. But for the second part you need x dash. That is the reason why they extended one line from x just and they have added one NOT gate, and the result is fed as an input to the second AND gate. Ultimately these two AND gates, result of these two AND gate is given to the OR gate at the end, and you are going to get the f4 or result. Fine. So like this you can see the gates, and using a Boolean function, how can you build the logic circuit? You have to understand like this. Fine. So you can take your own expressions, you can build your own logic circuit, and if you have any doubt you can get back to me. But make sure that you take your own examples and you try to solve and get the screenshot to me. Fine. You can send it that picture to the to my number. Okay, so I can check. If you have any doubt you can ask, otherwise you can practice. Fine, something like this. Now you have one more concept called algebraic manipulation. So I did not get any separate content on the internet and all, so I just taken the information from your textbook itself. Okay, so Boolean function can be minimized by algebraic manipulations. That means if the algebraic function, sorry, not Boolean function is very large, and if you have very complex Boolean function, then you can bring down that function and you can manipulate it. Okay, using some theorems or using some shortcuts, because you have seen some theorems in a previous video, isn't it? Something like say for 1 so x plus x dash is nothing but 1, something like that, isn't it? Do you remember that some of the I have listed out some points in the previous video? Correct. So postulates, I guess you remember that postulate concept. So it is I asked you to note down those postulate in some separate paper also, because to bring to simplify the expression you need those postulates, that expressions. So it will make your work easy. It will it will reduce the burden on the expression solving of the expressions. Okay, now here also they say the same thing. Boolean function can be minimized by algebraic manipulations. Unfortunately there are no specific rules to follow that will guarantee the final answer. You have to remember this. See whenever this algebraic manipulation, if someone is asking, if this is appeared in the examination, you have to ultimately write that particular statement. There are no specific rules to follow that it will guarantee the final answer, because one person can use his own postulate or his own idea, and one more student can take his own decisions. Ultimately, result may vary. I'm not saying it will definitely vary. It may vary based on the steps taken by them, because ultimately they can prove, see, this also correct, and the student, second student who has taken some other step also true if it is correct. But the ultimate result may vary. That is the difference. Fine. The only method available is cut and try procedure, employing the postulates, the basic theorems, and any other manipulation method which becomes familiar with the use. So they also say the same thing, postulates, and that is the reason why I said postulates are very important throughout your journey of this particular subject. So you have to note down those postulates separately, and you should understand by default when you see x plus x dash, directly it is 1, something like that. Okay, based on that only you have to take the appropriate decision. You can see the example 2.1 or 2 second example and first part. Simplify the Boolean, they have given some literals. Okay, so x plus x dash y, okay, equal to x plus x dash and x plus y. So they have made two parts, and when x plus x dash is nothing but 1, using that postulate, second postulate or first postulate, I don't remember the postulate number. You can if you have already taken down, you can check the postulate number, from which postulate, and otherwise you can go to the previous video and you can check. So this is a postulate. This is one of the postulate where 1 is nothing but x plus x dash. Now ultimately you have simplified the answer to x plus y. 1 into x plus y equal to x plus y. So what you have done, you have minimized x plus x dash y is minimized to x plus y. But it cannot guarantee that the same answer you may get. There may be a chance of getting the different answers also. That is the reason why in the second line they have said there is no we cannot guarantee. If you use the postulates or if you use some procedures, they cannot guarantee, but almost 99% the result will be same itself. But in some of the examples, 1 or 2 examples, you may see the variations. Okay, the second example, see x of x plus x dash plus y. So it is x dash plus xy. So x dash is nothing but 0 and xy. So 0 plus xy is xy. From where, how it became 0? X into x dash is 0. Again postulate. You have postulate, isn't it? And postulate and or postulate for positive sign and for dot sign. You have separate postulate values, and you are going to get some values for x plus x dash and x into x dash. Some values are there. They have just used those values and they got this result. Fine. So third one also you can see x dash y dash z plus x dash yz plus x y dash. Now what they have done, they have taken x dash z as separately, and they gone for y dash plus y. They minimized it plus x y dash. Now so y dash plus y is nothing but 1. So x dash z plus x y dash. So ultimately they have minimized the entire expression to x dash z plus x y dash. And for that x dash z plus x y dash, you can go for truth table also, as well as logic circuit, once you minimize the actual expression. So you may get such kind of questions in the examination. Minimize using algebraic manipulation, using some postulates, try to minimize the total expression and build a logic circuit and truth table. If that is the question, you should be able to do this. You have to take the common, you can go for some expressions, try to reach the particular postulate so that you can minimize the total expression into smaller parts, and then you can build your own truth table and logic circuit, something like that. Such kind of questions can be possible. So if you want, I will give some assignments, so you can try by your own. If you have any doubt, you can approach to me. Okay. Now fourth example is nothing but xy plus x dash z plus yz. It is somewhat different. See, so xy they have written in the same fashion, xz also same, plus yz into, so they don't have any other option to postulate. They cannot put the postulate to that expression. What they have gone for, they have used, they have added x plus x dash. What you mean by x plus x dash? It is 1. Do you change the values? No, you are not changing the values. Instead of changing the values, they have gone for that particular thing, isn't it? So ultimately x plus x x dash is nothing but 1. So you don't change anything, but you added one more part to that particular expression. Now after adding it, what you are going to do, xy plus x dash z plus xyz plus x dash yz, they just multiplied. Okay, after that what they have done, they have taken xy outside and 1 plus z they got. Fine. For the second part, x dash z 1 plus y they got. Now 1 plus z and 1 plus y, they have it became 1 and xy plus x dash z remained. Why it is like that? Again, try and that postulate and that procedure. Now ultimately what they have done, they have eradicated yz itself. They got xy plus x dash z. See how beautifully they have done that. So something like that, you have to add some postulates and you have to bring down. So basic expression, this Boolean algebra, if you have studied in your previous college life or school life, you are going to work on this particular concept in the same way. It is a basic mathematics. You are not learning anything new here. It is a basic mathematics. And that multiplication also, say inside the brackets, how can you multiply? The same concept they have gone for, but you have to remember the postulates. That is the main thing. Fine. Now see, fifth one is x plus y, x dash plus z, y plus z equal to x plus y, x dash plus z by duality from function 4. So they gone for that postulate function. So if you have the complete thing, directly you can reduce. Directly you going for duality. Okay, something like this you can work on that. So they have given some statements, the same statements what I have just explained, that function 1 and 2 are duals of each other, and they use dual expressions in the corresponding steps. The function 3 shows the equality of the function f3 and f4 discussed previously. So the concepts are very similar, but ultimately I have taken this example because using algebraic manipulation, how can you reduce the complexity of the total expression? That is the reason why I have taken this example. Fine. So like this you can work on it. Try to take your own expressions and try to build the truth table and try to build the logic circuits and try to minimize the total expression using the postulates. Okay, so for this video it is enough. Let me wind up the video and I will put the rest of the content in the next video. So yes, if you have any doubt, you can approach me. Thanks for watching.